So we're going to look at the sign of a quadratic. And what do we mean by that? We can classify parabolas as, and the first one we're looking at here is positive definite. Now the name tells you exactly what we're talking about. What this means is it does not matter what number we substitute into the function, it will definitely give a positive answer. And so what we end up with as far as the shape is a parabola which would be concave up and it would turn before the x-intercept. So it has no x-intercepts. So it doesn't matter what x value you substitute in, the y value would be positive. So the condition for that then would be, well, it's concave up, so a would have to be greater than 0, but the other condition would be the discriminant is less than 0 because it has no x-intercepts. It has a matching one called negative definite, so the difference there would be it would be concave down and have no x-intercepts. Indefinite then covers all the other ones. So you could have this one where it just touches the x-axis and is concave up. So that would be a is greater than 0, discriminant's equal to 0. And that's one where it's concave down. Once upon a time, it seems to be a terminology we've got rid of. We don't hear it much anymore. We used to call these semi-definite. As in, well, it's positive everywhere except this one point. But we don't seem to use that terminology anymore. We just classify them all as indefinite. And the other obvious ones are ones that have two x-intercepts. So really, we don't have to worry about concavity for the indefinite ones. The only thing we have to worry about is the sign of the discriminant. If it's greater than or equal to 0, then it's going to be indefinite. All right. Very rarely do you get a question about when is a parabola indefinite. It's more when is it positive definite, when is it negative definite. So what value of k would make this positive definite? Two conditions. So the first thing we have to check, a is greater than 0. So for this one, k would have to be a positive number. The other condition, discriminant is less than 0. So b squared minus 4ac. That gives us k squared is greater than 9, which of course gives us solutions k is greater than 3 and k is less than negative 3. That's why it's important to remember the concavity, because obviously that's not the final answer. Concavity has to be positive, so our final solution for this is simply just the ones where k is greater than 3. So remember, two conditions you need to check: concavity and also the discriminant as well. And that's it. Okay.